This is Megan Small. We're going to go ahead and work through Chapter 4, number 14 problem. So the question is, 3 workers at a fast food restaurant pack the takeout chicken dinners. John packs 45% of the dinners, but also fails to include the salt packet 4% of the time. Mary packs 25% of the dinners and omits the salt 2% of the time. Sue packs 30% of the dinners and fails to include the salt 3% of the time. You've purchased a dinner and there is no salt. We need to find the probability that John packed our dinner and then find the probability that Mary packed our dinner. The key here is to draw a tree diagram. So we're going to go ahead, draw one. J is going to represent John. M is going to represent Mary. And then finally an S is going to represent Sue. So John's overall probability of packing dinners is 45%. So we'll put that up top on him. Then we'll give him 2 lines to start off our tree. The top line will be salt included. And then the bottom line is going to be no salt. Based off the problem, we know that he fails to include salt 4% of the time. So we're going to put down here 0.04. On the top line, if we subtract 0.04 from the full 100%, we get 0.96. Then moving on to Mary. We know overall she has a 25% probability of packing your dinner. And we'll give her the 2 same lines. The top line will once again be salt and no salt. The bottom line is going to be 0.02. We get that from the problem of she has a 2% chance of omitting the salt. Subtract that from 100 and we get 0.98. And then finally Sue. She has 30% probability of packing your dinner. Same 2 lines of salt and no salt. We know from the problem she omits the salt 3% of the time. That's 0.03. Subtract that from 100 and you get 0.97. Now in order to figure out the probability that John packed your dinner, you need to find the overall probability that there is no salt. So you multiply across here. You'll do 0.45 times 0.04 and you'll get the total probability that John did not pack your salt of 0.018. You do the same thing with Mary. 25 for 0.25 times 0.02 gives you 0.005. And then finally, Sue, we get 0.009. Now, in order to find the probability that John did not pack your salt, you need what his initial probability is. So it's a 0.45% overall that he did pack your dinner. You're going to divide that by the grand total of the probability that there is no salt. So that will be 0.018 plus 0.005 plus your 0.009. When you figure this out, you get the total probability of 14.0625, or about a 14% that John was the one who packed your dinner. You basically do the same thing for Mary, except on the top you're going to do 0.25 and put that over your total probability that there was not salt included. So your 0.005 and then your 0.009. This equals 7.8125, or about, we'll call it 8%. So there's a greater chance that John packed your dinner this time than Mary. Because the salt was not included, you have about a 14% chance that John packed your dinner versus Mary only an 8% chance. Moving on to chapters 5 and 6 test, we're going to work on problem number 8. Scores on a recent national statistics exam were normally distributed, with a mean of 72 and a standard deviation of 9. We have a two-part question. Part 1 is, what is the probability that a randomly selected exam will have a score of at least 71? And part B is, what percentage of the exams will have scores between 89 and 92? Well, to answer the first part, it helps, or I guess I should say, to answer both parts, it really helps to draw your curve. So we're going to go ahead and draw our curve. My curve is a little bad, I apologize. But we're going to go ahead, and our mean is right down there in the middle. We know our mean is 72. And our standard deviation is 9. So for part A, we're looking at the probability that a random selected exam will be at least 71. So 71 would be about right here. And we're looking for the area in between there. In order to find that, we need our z-score. So we know our z-score formula is your score, in this case it's 71, minus the mean, which is 72, over your standard deviation, which is 9. When you compute that out, you get negative 0.1111, repeating. When you take a look at your z-score chart, this should technically just be 2 decimal places, I apologize. So it would be 0.11. When you take a look at your z-score chart and you find that value, you find out that the area in between there is 0.562. Now, you're not done yet, because you need to find the area in between there. That number just gave you your z-score value. You're going to do 0.05, because that would be your midway, and add it to that value. When you do that, you get 0.5438. That's your probability that the exam will have a score of at least 71. Now to move on to the next problem, you're looking at the percentage of the exam scores that will be between 89 and 92. Well, looking back at our normal curve here, 89 would be about here, and 92 would be about here. And you're looking for the area in between those two. This is where parts get a little tricky. You need to find the z-score of each. So, to find the z-score of 89, you do your score minus the mean over your standard deviation. So it's 89 minus 72 over 9. That gives you a z-score of 1.89. To find the second z-score, you do the same thing. You do 92 minus 72 over 9. And that gives you a z-score of 2.22. Then you go to your z-score chart. To this number, your 1.89 z-score has a value of 0.4706. Your 2.22 has a z-score of 0.4868. Okay, now we need to subtract the two. We're subtracting the two because they're on the same side. We want to find the area in between here. So we're going to take 0.4868 and subtract it from 0.4706, and that gives you a value of 0.0162. And that's the percentage of exam scores that will be between 89 and 92. And finally, Chapter 9, we're going to do question 17. 17 says, the mean length of a work week for the population of workers was reported to be 39.2 hours based off the Investor Bureau's report. Suppose that we would like to take a current sample of workers to see whether the mean length of work week has changed from the previous reported 39.2. So just right off the bat, I like to write down that we know our mean is that 39.2. Okay. Part A. State the hypothesis that will help us determine whether a change occurred in the mean length of the work week. So we're looking for our null, our H sub 0, and our alternative H sub A. Our null hypothesis is going to be what we would like to find out. So we want to know if our mean is going to stay the same. So we're going to do mean equals that 39.2. Our alternative, is going to be the opposite. So this is going to be our mean does not equal 39.2. We're not going to use any less than or equal to signs here because we're just looking if our mean is still what it was reported to be or if it has changed or not. So it's not whether if it's above or below, it's just whether it's equal to or not equal to. Moving on, Part B. Suppose a current sample of 112 workers provided a sample mean of 38.5 hours. Use a population standard deviation of 4.8, What is the p-value? So the values that were given here are n equals 112. Our mean is now 38.5, and our standard deviation we know is 4.8. So in order to solve for the p-value, we need our z-score. This is a little tricky. Our score that we have, because we know our z formula is your score minus the mean over the standard deviation, our value is 38.5. So this is going to be our score minus the mean, which we know from previously is, that should be a 3, 39.2, and then we're given the standard deviation in this problem, which is 4.8. And this gives you a z-score of negative 0.15. When we look at our z-score chart, we find the p-value to be 0.0596. And we will need that for part C. So moving down a bit here. Part C asks you, at sigma equaling 0.05, can the null hypothesis be rejected? What is your conclusion? So sigma equals 0.05. In order to figure this out, I drew our standard curve. So here's our standard curve. We know our mean is that 39.5. Alright, so then we can figure out where sigma lies based off of that halfway point. So that's 0.5 minus our p-value from earlier, which is 0.0596. And this will give us our halfway point right here, or a value right here. and that equals 0.4404. Alright, I also know I can put the same value on the opposite side of 0.4404. Just because we are on a standard curve, it is going to reflect. So just to completely fill this in, I know negative 0.15 is here, and then 0.15 is also here. We just found the area underneath those with our 0.5 minus our p-value. Alright, so now what we do with these is we're going to multiply it by 2. We do that because we want the overall area underneath our curve. So we're going to multiply it by 2, and that gives us 0.8808. Now we have to ask ourselves the question, is 0.8808 less than or equal to our 0.05, our alpha value that we were given from earlier? The answer is no. So we accept our null hypothesis, which means that the mean has not changed, which means that the mean has not changed and our average work week is still that 39.2 that we were given in the very beginning. And those complete all my problems. Once again, this is Megan Small for our statistics class.